Hi girls, so this will be the first of two short videos that I'm going to make for you tonight. So the first one's about rational functions, which you'll also see the word reciprocal functions, things like that. Rational functions, I mean we know rational numbers, right? Rational numbers are that set there, and it's the set of things which I can write as a fraction, a over b, where a and b are elements of the whole numbers, or the integers, right? So rational functions are the same things. A rational function looks like something like this. Where A, B, two fingers needed, C and D are real. Right? If you've got a rational function, that is what it looks like. And it turns out you can rewrite all of them in the form something like a over bx plus c plus d, right? And once I do that, I can always sketch it. So, for example, I'm going quite quickly here, but this should hopefully be things you know from year 10 or something. Right, if I wanted to sketch that, I can immediately identify the intercepts. And I mean, again, this is all in the graphics calculator, right? But the intercepts are, the x-intercept is 1, because we can't divide by 0, and the y-intercept is 3, because we can never make this bit here that I'm highlighting in yellow 0. You can't divide 2 by a number and make it 0. You can make it incredibly small, but you can't make it 0. And then the 2 at the top there just tells you how steep it is. The bigger the number, the steeper it is. So, I mean, something like that, right? And then the thing to do, I've been a bit flippant there. I don't really know what happens in there. So what I should really do is say when x equals 0, what happens? Y equals 1. So that looks reasonable. I mean, it doesn't look great, but it looks okay. And then when y equals 0, I also calculate what x equals 2/3, I think. I'm not sure I did that in my head, it's probably wrong. Anyway, the point is that it does cut through the axis like that. Okay, so you should find the intercepts there. But the point is that any rational function you're given, you can write like that. Okay, so if I give you an example, there's one. So if I do y equals 2x plus 1 over x minus 1, the way to do it is you basically want to look at the thing on the bottom and say how many times can I take that out of the numerator. So there's 2x minus 1's in the top because of the 2x term. And then what did I do there? Okay, so I just going to have a sip of water. Very refreshing. So what I did here was I effectively subtracted 2, right? When I expand this bracket out, it'll be a minus 2 there. I need to get back to plus 1, so I need to add 3. So now this is 2 plus 3 over x minus 1. And then I can sketch it. Right? I have the same intercept there at 1. I have 2 there. Again, I could put this in my graphic calculator quite easily all the way from the start, but if we don't understand these things, then we're not going to be able to do more difficult things with them. And then we can say what happens when x is 0, well, y equals minus 1, and when y equals 0, x equals minus a half. Just as a note, to do that one quickly in your head, go back to the start and look at where the numerator is 0. That's the only way to make y 0. And so I sketch it. God damn it. Something like that. Okay, well that's minus a half, and that's minus 1. And that is essentially rational functions, right? It's all about they're all hyperbolas, and it's all basically about asymptotes. And you can do a lot of things, like, you know, you can analyze what happens, and this is all stuff I'm sure you would have done before. But if you just look at like y equals 1 on x minus 1, you can do kind of not a sine diagram as such, but you can analyze what happens when x gets really close to 1 from above. So you could say, what happens when x is like 1.001? Well, y ends up being like 100. And then when x is y equals 1.0001, it's like y equals 1,000. And so that is explaining why there's an asymptote there. If you want me to do more of that, I can do it in front of you, but it's better to do it in front of you. But that's why it works. Okay, that's all for this one. I'm going to do a quick one now on inverse function intro as well. Bye.